Lesson 3.3. Topic is still logarithms. We're getting specific here to three more properties that can be kind of used to simplify expressions. They may come up in learning targets 4 and 5 when we start to solve. They don't all that often, but really simplifying, a little bit of evaluating too, is the name of the game. No graphs in section 3, kind of an algebra focus that we'll take with these new properties. First one I want to talk about is really more, it can be used to simplify, but it's more for evaluating. It's called the change of base, and really what we use it for more often than not is if we want to evaluate a log of any base It's always worth noting here that this doesn't have to be there when you write it out, but A's got to be greater than 0. You do have to make sure A isn't 1. And B also has to be greater than 0. The change of base says this, that if you take log of any base of B over log of the same base of A, that expression right there as a ratio is equivalent to the one that you started with. Okay? You will see that it works for any base, but you will find that far more often than not, we switch to 10 and we switch to base E, right? There is, like, you can use the change of base formula to do a lot of stuff. The most common way it shows up for us is if we want to evaluate a log of a particular base. It just makes our calculator easier to use. Okay, let me show you what I mean. Let's say we had log base 4 of 25. Okay, now as far as evaluating without a calculator, we have talked about how what you really are asking here is 4 to what power is 25. Okay, and if the numbers work out nice, you can probably just guess and check, maybe in your head or with the help of a calculator. But if the numbers aren't nice, guess and check is going to be really tough. Now there's an easy to use log base 10 button on your calculator, and this is a decimal that's not going to come out nice from looking at this. I can tell it's somewhere between 2 and 3, because 2 squared is 16 and 4 squared is 16 and 4 cubed is 64. Probably closer to 2 than 3. But to get a really, really good approximation, that's the best way to go, is to put log base 10 of 25 over log base 10 of 4. And your calculator would give you a real long decimal that we would just round to 2.32. Similar example. Log base 2, and this is an important thing to talk through because sometimes people get confused about it. Let's switch it to ln. All right? So what's the difference here if I switch it to a natural log, which is base E, as opposed to switching it to base 10? And the answer is nothing. Okay, the change of base formula is structured so that it works for any base x, like right here. We didn't say anything about what that base had to be, right? Any base. We go to these ones because they work really well for a calculator and they're easy to evaluate. Now if you wanted to check that one and did log base 10 of 12 divided by log base 10 of 2, you would get the exact same thing of about 3.58. Okay? You could switch it to either 1. Now, if you look at that and you're like, if log base 10 always works, couldn't I just always do log base 10? And you certainly could. Okay, you could always do ln, you could always do base 10, but one of those two is what you're going to want to switch it to. All right, here are the 3 new properties, and I've basically got a handful of problems that we're going to use these for. I don't want to spend a lot of time talking about them here. The bottom line is in your notes. You just need to get them written down. Notice the names. This is about the only thing I want to say. For product, it's talking about a logarithm that is written as the product of 2 numbers, one that's being divided, and one that has an exponent. Okay, something you'll have to be a little bit careful of, though, is notice on the product, when you split it up, okay, and when we get to those examples, we call that expanding, right? Taking a logarithmic expression and expanding it, it gets split up with addition. And in a similar fashion, a quotient gets split up with subtraction. That can be a little bit tricky. Okay, the third one is a little bit different. It's where you take an exponent out and you can turn it into multiplication. Make sure you have those handy, because I'm going to refer to them a decent amount. Okay, so that's kind of 4 different types of examples I want to do here. For the first ones, let's write in terms of ln2 and ln3. For example, how would we do that with ln6? Write it in terms of ln2 and ln3. Okay? Now these examples have been set up so that the numbers work pretty well. And you'll see sometimes if the numbers didn't work out well with the numbers you were given, you know, we can rewrite logs in terms of other numbers, but it doesn't always work out as well as we would hope. Depends on the problem, on the numbers we have. Okay. Now here's where your property comes into play. Is you could take this and say ln2, because I've got it set up that these two are being multiplied. I've got ln2 plus ln3. Okay, that might be one you want to look at closely to see that it matches the structure of the first property that you got. Okay, and at that point we'd be done. Part B, let's go. I'm going to stick with natural logs, obviously. I'm not going to mess around with changing the base. How about that? What if it was ln2 over ln27? I would use my quotient property, and I could say ln2 minus ln27. And the ln2 looks fine. The 27, I got to somehow rewrite that in terms of ln3. This might be a tricky little step to do, but I could write 27 like that. And then I'm going to my power property, pull the 3 out front, and that term is now written in terms of ln2 and ln3, because it's natural log 2 minus 3 times the natural log of 3. Let's switch the instructions. We're going to use the same properties, but let's say now, let's find the exact value. Example A states log base 5 of the cube root of 5. Log base 5 of the cube root of 5. One thing that's going to come up on several of the exercises you'll see in section 3 is taking a cube root or a square root and converting it to an exponent. A cube root is the same as raising a number to the third power. Likewise, a square root is the same as raising a number to the 1/2 power. Okay? A lot of times when you're simplifying, you may want to switch it to one way or the other. Like right here, the first thing I want to do is to take that cube root, switch it to the 1/3 power. Because then what I get is a log base 5 and an exponent of base 5 cancel, and I'm just left with 1/3. That problem actually didn't use any of our new properties. It used the old one that a log and an exponent of the same base will always cancel each other out. Natural log of e to the 6th power minus the natural log of e squared. First thing I would do here is use my power rule to take the 6 and bring that out front and do 6 times ln e minus 2 ln e. And we will definitely have some work to do going forward to kind of take all the properties of logarithms and combine them, and thinking in terms of your test and your note card, because there's a lot of them. And I bring that up here because this now goes back to an old one. We have a property that tells us the natural log of e, okay, which can be a little bit tougher to see because what's happening is you have a logarithm and a base that's the same. Okay, what you're taking the log of and the base is the same, that always ends up being 1. And that shows up twice, which leads us to just 6 minus 2, which is 4. Okay? So sometimes, using the properties, a logarithmic expression can be written to be dramatically simplified. All right. Next set of problems here. This is the last slide for the day here. I'm going to give 2 different instructions. I'm going to start with the instructions to expand. Okay? I got 2 of these that I want to do with you. Something like this. Log base 4 of 5x cubed times y. Okay? Notice we have one log that's written base 4. Okay? And what's in there is kind of complicated. 5x cubed times y. I guess it's not super complicated. There's just a lot in there. If you're given the instructions to expand, it's very likely that you started with a single logarithm, okay? And you want to write it as an expression that is the sum or difference of several, okay? Now this is based on multiplication. So the first step I would make in expanding this would be to take log base 4 of 5 plus log base 4 of x cubed plus log base 4 of y. And we've almost completely expanded. There's one more thing we need to do. This third power can come down here and be 3 times log base 4 of x plus log base 4 of y, and there you have it. Okay, that expression has been completely expanded. Okay, it's been written as the sum of 3 logarithms. Each one is relatively simple. Okay, whereas before we had one that was a little bit more complex. Let's do another one. Let's do ln. Let's pick some funnier terms that may or may not work out nice. The square root of 3x minus 3x minus 5 all over 7. The very first thing I see there is that fraction is a division sign. So I would take these 2 terms and I would get those split up with subtraction. Okay? And again, that's you see how I've expanded it now. as before it just had one ln. Now it's the difference of 2. Another case where we want to deal with that square root, that's like taking 3x minus 5 and raising it to the 1/2 power. So let's use the third property that we saw today. Pull that out front. And that actually does it. Okay, that's as far as we could take that one. Okay, it's tempting to look at ln of 3x minus 5 and to think that we could keep going with that, but we can't. Okay, if you look at there, the two terms inside the natural log are being subtracted. We have a property if those two terms were being multiplied or divided. Nothing we could do to simplify it if it's being subtracted. So that's actually where we would end on that one. Now, probably not going to be a huge shock here what we're looking at next. Another instruction that you could get is to condense. If you were condensing, you could get something like this. 1/2 log of x plus 3 log of x plus 1. Same properties, applying them in the opposite order. Okay, applying them in the opposite order. If your instructions say to condense, as far as what you're given, you would expect an expression that's longer. It's kind of like one of the answers to the problems that we just did, and you want to condense it down. These can be a little bit easier to approach because you kind of know your ending point. You should get it down to an expression that has 1 log. That's when you would be, I mean, if it's possible, that's when you would be fully condensed. Okay? The way I'd start this one is that 1/2 needs to come in. Okay? And that 3 can come in and could be the third power. Okay? Now you'd really have the option here. You could leave x to the 1/2 power. It's up to you. For a final answer, I would prefer it written as a square root. That's just me. I would have no problems if you just left it. The step that would have to happen here is these two need to get combined into 1. Okay, using multiplication. Okay, so you'd have the square root of x times x plus 1 cubed. Okay, notice we don't have 2 logs being multiplied anymore. Or excuse me, 2 logs. We don't have 2 logs being added. What we were taking the log of is now being multiplied in a single logarithm. Okay, which would fit our first property, the product rule. Now here's another one. Take 2 ln of x minus ln x. Okay. This is a good time if you wanted to like pause these. I mean, you could try them on your own, and then you can get immediate feedback if you did them correctly or not. So there's two more condensing ones that we're going to do, and that's going to be it for these notes. So feel free to do that if you would like. First thing I'm going to do is look at my first term. I want that squared to come in. Okay. And I really only see one thing that's left. I have 2 logs that are being subtracted. I'd like them to be combined into 1, which I could do as x plus 2 squared all over x, and that would actually do it. Okay, notice I have it down to 1 log. Okay, now here's another thing. Sometimes you might look at that and be like, x plus 2 squared, couldn't you like expand that and FOIL it? And yeah, you could simplify what's inside that natural log. However, okay, the instructions to condense just mean you have to get it reduced down to one log, and we did. Okay, so it really isn't about what's left on the inside. I could certainly just leave it like this, and that's kind of what I would expect you to do. One kind of side note with all these, it's been kind of obvious, but it's worth noting. To use these properties, you have to be dealing with the same base the entire time. The very first thing I showed you at the beginning is how to change bases. That's not something we do a ton of. So on all these expanding and condensing, that's not going to be a thing. All right, you know, the first one was base 10. This one was, you know, natural log, and this final one we're going to do is base 2. But notice the whole time there's no changing bases. How about 1/3 times log base 2 of x plus log base 2 of x plus 1. Okay. I got to start inside these brackets. Okay, the 1/3 I'm feeling like is going to come inside as an exponent eventually, but I got to start inside. And I've got these two logs that I can bring together. They're being added, so my first property says I could do 1 log of x times x plus 1. Now I'm thinking about bringing in the 1/3, which again, you could do it in one of two ways. You could just bring in the 1/3 if you would like. When I bring it in, I like to write it as a cube root. Okay? If you had that whole thing of x times x plus 1 to the 1/3 power, that would work. Okay, that would certainly work. I like it written as a cube root. Notice I could distribute the x on the inside. You can. It wouldn't be wrong to have the cube root of x squared plus x. But the instruction said to condense, and almost caught me by surprise here. I got to make sure I have that in there. I almost forgot I was dealing with log base 2. Right? It's very, very important that those are there, because that's what I was saying before we did this problem. Is you know, if I didn't write those, it would look like I switched from base 2 to base 10. Not the case. I mean, when we're using these properties, we can't be switching bases. You wouldn't be expected to, so that does need to say log base 2. But that one is finished again because it's condensed fully because we're down to 1 log base 2.